In this video, we will solve some exercise on systems of measuring angle. Question number 1. Find the length of the red arc in each of the following circles approximating the result to the nearest tenth. We start with letter A. In letter A, we have R equals 5 centimeters and R is the radius of the circle. And we have theta, the central angle, which is opposite to the length of the arc, L, equals 90 degrees. And the relation between L and R and the central angle in this rule, such that L equals R theta radian, theta in radian measure. So we must convert from 90 degrees to theta in radian. So we'll use this rule. Theta radian over pi equals the measure of the angle in degrees, theta degrees, over 180. And then from this form, the required here is to find the theta radian. So theta radian equals theta in degrees multiply times pi over 180. So theta radian equals 90 degrees times pi over 180, which equal half pi in radian, such that 90 divided 180 equals half. So the length of the arc L equals 5 centimeters. The length of the arc must be in centimeters, not meters, not any something else. So 5 in centimeters times pi times half pi. So we'll multiply it using calculator. 5 over 2 pi. So we will convert it to decimal number. It will be 7.885 equals 7.85 equals approximately 7.9, because the required here is to find the length of arc approximating the result to nearest tenth. To nearest tenth, it is equal to 7.9. In letter B, we have R, it is the radius, equals 8 centimeters, and theta in radian measure equals pi over 3. So the length of the arc denoted by the symbol L equals R times theta radian, which equal 8 centimeters multiply pi over 3, and we can calculate it in calculator. Which equal in decimal 8.37, approximately equals 8.34, approximately to nearest tenth equals 8.4 centimeters. Here in letter C, R equals 6 centimeters, and theta radian equals, see it again, 7 pi over 6. 7 pi over 6. So L equals 6 times 7 pi over 6, which equals 7 pi radian, which equal, we must complete the solution, multiplying 7 by pi, which equal 7 pi, but we must convert it to write it in decimal, equals approximately 21.9 centimeters. Now go to second question. Here it is very important question. Here the figure opposite represents the measures of some special angles. Here we have 30, 45, 60. These three special angles in first quadrant. In second quadrant we have 120, 135, 150. It is also special angles in the second quadrant. In third quadrant we have the special angles in radian measure, and the required in this question to find the measure of 120. Here it is given in degrees. The required here is the measure but in radian, and in this quadrant, fourth quadrant, the required is to find the measure of the angle in radian measure also. Here the required is to find it in degree measure. So we'll solve it quickly, starting from here. The very important rule we will use is theta radian over pi equals theta degrees over 180 degrees. So we will answer. So we'll find the angles in second quadrant. The given here is the measure of the angle in degrees and the required in radian. Just we substitute. Here we write theta radian over pi. It is equal theta degree 120 over 180. So theta radian equals 120 over 180 multiply pi, which equal, you can divide up and down by 10. So we have 12 divided by 10, also we have 18. Dividing by 6 equals 2, dividing by 6 equals 3. So it is equal to over 3 pi with respect to 135. Again we have the same rule, theta radian and you can simplify this fraction. 135 3 over 4 pi, and the result here is 3 over 4 pi, and the same with respect to 150. Equals 5 over 6. 5 over 6 pi. And the same here, the same rule to convert from theta radian to theta in degrees. We have the rule. We can use another color here, theta degrees. It is required equals theta radian over pi multiply 180, which equal theta radian here, it is 7/6 pi over pi multiply 180. Pi divide pi equals 1, so it is equal 7/6 multiply 180. Dividing up and down by 6, divide 6 equals 1, divide 6 equals 30. So it is equal to 210 degrees. 210 degrees. And it is lying on the third quadrant, included between 180 and 270. The same with respect to 5 pi over 4, 4 pi over 3. And the same rule we will use here. We'll choose some of this, one of these three angles. The angle here of measure 315, and we wanted to convert it to radian measure. So we expand the paper. We have the required here, don't forget to find theta radian. So theta radian cross multiplication, it is the required here. Theta radian equal theta degrees times pi over 180. Again, theta degrees times pi over 180. We have 315. Which equals 7/4. So the result equals 7/4 pi.